So, we may be interested in measuring the linearity. Okay, there are differential linearity, integral non-linearity of A to D converters. So, those also need to be measured. Okay. So, the difference between digital and analog testing is, see, in digital testing the size is a problem, the number of gates is very high, but in analog testing that is not really a problem. Analog ICs do not have a lot of transistors, okay. There are maybe hundreds of transistors, but on the other hand there is no analog fault model, the signal range is infinite, right, and there are tolerances in the manufacturing process, right, and when we make measurements there may be error in the measurement. This error is hardly going to affect us in the digital case, right. That is what I meant by saying, when you measure a logic high, the actual value is not important at all, whether it is 1.8 volts or 1.7 volts does not matter, you only care about whether it is a logic high or logic low, but that will not work in analog. And there may be noise in there may be what is called as coupling that happens between the digital and the analog parts through the substrate. So, that also may be a issue. Then the components have tolerances, okay, and there is no unique signal flow direction, right, that is another problem. So, many times you may have to test the functionality in an overall way rather than go and test all the individual parts. So, it is more of functional testing that we are referring to than like digital tests. In digital circuits, we say, is this node stuck at 0 or stuck at 1? See, that kind of a thing we cannot possibly practice in analog. So, we look at the overall functionality. Then recently they have introduced some analog test buses, right. So, we will talk about that analog test bus little bit later. Okay. So, the analog testing is usually spec based, that means we want to know whether the parameters like THD or SNR are within the specified limits. So, that is what it is, specification based, and we use functional testing, we do not use structural testing. We are not interested in looking at how this analog IC was made, and we do not want to know a particular transistor and look at whether it has failed and things like that. That is not the level at which we are planning to test. We are sort of looking at the analog test as the analog IC as a black box, and we want to apply certain inputs and make measurements, calculate the parameters, see if it is within the limit, and if not, reject. On the other hand, I think it is all still research to do any kind of ATPG etc. for analog test. And DSP may be used in testing analog circuits. Okay. So, we may take the output of the analog circuit and use a DSP to sort of measure things like the nonlinearity and things like that. Okay. So, increasingly we use digital signal processing such as Fourier transform, wavelet transform, etc., in order to make measurements. Okay. So, here the word DFT stands for discrete Fourier transform. Unfortunately, DFT also means design for test, but in this context it means discrete Fourier transform. So, the concept of the analog tester is you have to take your design under test, which is a linear IC such as maybe an operational amplifier, and you apply various inputs to it including DC or noise or sinusoidal, and then look at the output. Okay. And you may be interested in measuring the DC value in the output or the RMS value of the output, peak value of the output. So, it is mostly measurements, and based on these measurements we try to check out whether this part is worth keeping or discarding. Okay. So, the output of the DUT okay, or the design under test may have to be digitized, right, and then we may have to process that digital output in a DSP. And similarly, the output of the DSP may have to be stored and converted back to analog. So, we may use the DSP to generate waveforms or to analyze the waveforms. So, it has both the okay. So, DSP can be used to generate waveforms or to analyze waveforms. So, that is the reason why we use DSPs. Okay. So, here is how one may apply a DSP to synthesize sinusoidal waveform.